everyone, welcome back to the channel of Ecoholics. So today's video is going to be very interesting for you. As you can read the title on your screens, it reads easiest way to find elasticity of substitution. Now elasticity of substitution, I have seen for many students, it have been next level to horror because they say that we get stuck while we are solving questions. We forgot, we actually do not, they say we forget that what we were solving, with which respect do I need to do the derivative, how to proceed further, the production functions are so complicated, how do I do that? So there have been a lot of recommendations we were receiving from you guys to come up with this trick. So in today's video, I will be teaching you the most easiest method to calculate elasticity of substitution. Now, either you are the one who is right now in your undergrad, postgrad of economics, whether you're preparing for any competitive examination like RBI, IES, UGC, any other, this is going to be helpful for you. So, the trick I'm going to share today can be used for any of the production function. It just requires your knowledge of calculating derivative. And that's all. And the second thing you have to bring before you get into the video is patience and not getting anxious. So the first thing is, what is elasticity of substitution? It is the ratio of percentage change in capital labor ratio with percentage change in marginal rate of technical substitution. So percentage change in capital labor ratio divided by percentage change in MRTS. In other words, it measures the degree to which two factors of production, which are capital and labor, can be substituted for each other in the production process while keeping the level of output constant. Very important thing to remember. So in a competitive market, it measures the percentage change in two inputs in response to percentage change in their prices. Now, this is what I have written is something this is the only trick. The definition written here is the most easiest definition you will ever find. So this is the only trick which we have to use. How? Let's learn it through the example. So this is the production function in front of you, which is a Cobb-Douglas production function. So for calculating elasticity of substitution, we need the value of MRTS. And not only MRTS ki value you have to find, but you can find elasticity through that value only. Sounds interesting? Let's see how. So first thing is, I would calculate. Now, for example, if I want to calculate elasticity of substitution between K and L, so it is equivalent to del log K by L with respect to del log MRTS. Now, this log basically represents the percentage change here. Okay, so how we will go about the same? So first we will find MRTS between K and L, which is equivalent to partial derivative of production function with respect to L divided by partial derivative of production function with respect to K. Now, if I use the same trick here, I would be getting A into alpha, L, alpha minus 1, K into beta. Then it would be A, beta, L raised to the power alpha, K, beta minus 1. So this is partial derivative with respect to L and this is partial derivative with respect to K. Now I know few terms will cancel each other out. So this is MRTS. This will give me alpha by beta. Now this is beta minus 1, this is beta. Beta minus 1 is just 1 power less than beta. So I would get K here. Similarly, I would get L here. Now this is MRTS. Here we have already got the answer in K by L. But what if you have a CES production function? You will not get the answer in K by L. So the trick is that when you find MRTS, you get something like you get it as a function of alpha, beta, or whatever the other parameters are, L, K. But the trick is that you convert this. You can leave the parameters aside. You do not have to bring a change in parameters. Just do this thing that the K and L terms, you try and convert them into the form of K by L. So you convert them into per capita terms, basically, K by L. So if you do that, nothing can let you get full marks in the question of elasticity of substitution. Okay, so here it is already K by L. If it would have been something else, I would have divided, multiplied to get to K by L. Of course, you can have K by L power square. You can have any other power of K by L. But the only objective is to get it in K by L, although you can have other functions as well. Now, after this, what I will do after getting this MRTS, now the next step requires you to, I will choose another color so that you know this is first step, this is second step. Now the next step requires you to take log on both sides. So log MRTS is equivalent to log alpha by beta. Since these are in multiplication, so by after taking log, you will get a plus here. So log K by N. Now the last step. So I will write this equation, this last equation on the next page. So this gives me log MRTS is equivalent to log alpha by beta. Now you're just one step away from your answer, you know. Log, what was here? K by L. This is what you get. The last step requires you to differentiating this equation with respect to log MRTS. That's all you have to do. Now, doing the derivative of log MRTS with respect to itself gives me fun. Log alpha by beta is a constant number for log MRTS. So derivative is 0. Constant number ka derivative is 0. The derivative of log K by N with respect to log MRTS is equivalent to elasticity of substitution. So this is sigma Kn. So what is my answer here? Sigma Kn, elasticity of substitution in a Cobb-Douglas production function, is equal to 1. Can you see in how easily we have found out the solution? You can do the same exercise for CES production function as well. So at the end of this video, I give you this task. Choose a CES production function, try and use this method. And I believe you will be able to solve it very easily. CES production functions can look complex, but when you will do their partial derivatives, the complexity will go away. So don't get anxious, be patient. You will be getting your answer. And do let me know in the comment section below whether you have been able to solve CES production function using this method or not. If you will find difficulty, I will come up with one more video for solving the elasticity of substitution in a CES production function. I hope you will enjoy watching this video and like this video, share it among your friends so they can also make use of this. Thank you for watching.